Welcome to the time series final project presentation. This project will be based on the Bitcoin series. The layout of the presentation will be as such. We will have a short introduction about the Bitcoins and the dataset. We will then look at the characteristics of the time series itself. We will then dig into some of the findings, followed by some model specification. After specifying the models, we will touch base on the residuals, followed by the model selection. And lastly, we will be forecasting the next 10 days of the Bitcoin prices. So a short introduction about Bitcoins. So Bitcoin was actually the first cryptocurrency introduced in the late 2008 and early 2009. So what is a cryptocurrency? A cryptocurrency is a form of currency that only exists digitally. And the value of a Bitcoin is determined by what people are willing to pay for it. Which makes it actually very volatile and fluctuates widely. The data set we'll be using has been obtained from the coinmarketcap.com website, and it includes the daily closing prices of the Bitcoins from the 27th of April 2013 till the 24th of February 2019. Moving on to the characteristics of the time series, we observe that there is a trend in this series. In terms of seasonality, there is nothing obvious from this plot. Changing variance is very clear. Autocorrelation, yes. Intervention, maybe something could have happened at the highest peak, which could be further investigated. And if we take the SCF shows a slowly decaying pattern, which means that there is trend and non-stationarity in the series. The PACF shows one significant first lag as well as many other lags throughout the series. So our findings till now are that the series is definitely not stationary, and that there is clearly some arch effect in the Bitcoin series. So we then decided that we would apply first order differencing. Moving on to specifying a model, we have plotted the ESCF and BIC table to identify orders of P and Q. The ESCF table shows some fuzziness, and we have identified a combined set of models, namely ARIMA 212, 213, 110, 510, 610, 011, and 016. After ensuring that the series is stationary and specification of orders of ARIMA models, our next step is to estimate the parameters of the tentative models. For the purpose of this project, maximum likelihood is being used, and out of the tentative models we have identified on the previous slide, ARIMA 011 scored the lowest AIC. And the coefficient on this model returned significant for all coefficients except for ME3 and ME4 component. Moving forward, we will be testing the goodness of fit of this model. So on this slide, we are looking at the plot of the residuals. So the residuals all seem to be lying within the range of -3 and 3, which is a good thing. Now that we have fitted the ARIMA model, we will be using the residuals to figure out the arch effect. And in that regards, we will plot an EACF table of the absolute values. Before that, while plotting the ACF and PACF of the absolute values of the residuals, we still observe significant correlations, inferring that the series is in fact serially dependent. We then use the EACF to find the order of the gauge model. From the EACF table, we will then apply a gauge of order 1, 1 to the residuals of model diagnostics on the next slide. The plot of the residuals after applying the gauge 1, 1 are shown. The graph on the top left is showing the distribution, which seems rather symmetric. The QQ plot is assessing normality, and below plots are ACF of standardized residuals versus ACF of squared standardized residuals. There are no lags in the squared standardized residuals, which suggests that the square residuals are uncorrelated over time. Since we are rather satisfied with these results, we will then be forecasting the next 10 days of pricing the Bitcoin series, which we haven't done yet. Thank you for your attention, and we will welcome any feedback and comments. Thank you.